Welcome to this JavaScript prototypes and classes topic video. Okay, we're going to be talking about prototypes and classes. Our objective is to understand this weird double underscore prototype double underscore property in JavaScript. This is something that we get with JavaScript objects, and understand it's got some chaining features, whatever that means. We're going to see that this enables object-oriented programming, OOP, type of inheritance. Okay, we're going to learn to use JavaScript class, the JavaScript class declaration, to create OOP style classes, which of course we then use to create objects. We're going to also learn about the extends declaration, which allows us to do inheritance in the OOP sense. Okay, so let's get into this. Okay, there's some references. I'm not really telling you to go do the readings, because if you need to, if you run across some things that involve prototypes, okay, then go and read these to understand them. They are good references. Okay, but in this class, we're going to use classes, and we're going to see that they're intimately related. So we'll be relieved of some of these things. Okay. The basic class reference here is MDN. Okay, and that gives you the syntax and such like that. These will give you some more ideas about how they work and why you should use them rather than other approaches. Okay, try the examples here. They're going to help things sink in. So first of all, this underscore underscore double underscore proto underscore underscore property is in ES6, the ES6 standard, but it's been around for a while. Okay, so let's check this thing out, see what it does. Okay, so here I define an object. Here I define a completely separate object. Okay. Then, though, for the second object, I set this underscore underscore proto property equal to the first object. Okay. Then we're going to take a look, and then we're going to try something odd here. Okay. Object B, my object B, right here, has no property named stuff. Okay, it just has course and students. My object A has a property named stuff. Okay, so let's copy that over. Go over to our, clear that out because that's messy. Okay, let's paste. Okay, and let's first define things and then run them. So we're going to first define all those things. So we see my object B is stuff. Think about a number 42. My object A, stuff. Think about stuff. It's got a number in it. Okay. Oops, sorry. Think about stuff. This looks like object A. Okay. Let's double check my object B. My object B. Okay. Course, students, blah. Okay. Now, let's paste those two lines we didn't use already. Okay. Console log. Okay. Course, students. Got two fields in it. Now, finally, let's try console log. We should get an undefined here, we think, or not. Wait, object B has course and students 34. However, when I went to go get it and ask it about stuff, it printed out stuff. My object B dot stuff. It's there, but it doesn't show up here. Interesting. Let's try it some more. Okay, we got three objects. Object A, stuff and number. Okay, okay, stuff and number. Clean that stuff up before we do this. Okay, we got stuff and number in there. Object B has course and students. Object C has music and guitarist in it. Okay, let's copy this up, paste it in. Okay. We'll wait to run those things. Okay, so we define those things. Now, oops, let's do some funny stuff with the, over here with the proto properties. Okay, I'm going to say object B proto to A, object C's proto to object B. Okay. Okay, now let's console log these things. Object C and object C number. So object C has the music type metal baroque and guitarist JS Bach. When we print out the number, we get this number 42, but it doesn't appear that object C has a number 42. However, the proto, as we'll call it, of object C is object B. It still doesn't have a number field, but object B's proto is object A. What's going on here? This is known as the prototype chain. Okay, so we are going to look at objects, my object C. Okay, well, let's just copy this and do these one at a time. This isn't clearing the variables, it's just, okay. So let's see what object C is in my object, in object C underscore underscore proto. Okay, object C is just what we expected. Underscore underscore proto. Okay, well, that's what we set it to. But and then, what if we go, oops, not that. What if we go, oh, let's look at all of these. Object, oh, this looks like A. So that's right, because we set A's. We set B's proto to A, etc., etc. Then we get, finally, up to no. JavaScript looks for properties, including functions, on every object in the proto underscore underscore proto chain until null is encountered. So we can just keep going proto, proto, proto until null. Okay, so my object C does have something called number in its prototype chain. Oh, so we can kind of build objects and relate them to each other? Okay, let's see how this works. Okay, so we've talked about, once again, this doesn't erase those things. We've talked about iterating through objects. Okay, so let's iterate through var prop in my object C. It says prop has value blah. Okay, let's see what this is going to do. Oh, music has value metal baroque, guitarist has value JS Bach. It looks like it's going up and looking at all the properties in the prototype chain, right? Because the first two are from object C, second two are from object B, and the last two here are from object A. Oh, let's try this other statement. The keys for object C, console log keys are object C. Oh, the keys are just its own properties, the ones that it didn't inherit. Oh, so these two things behave differently. For in loops traverse all enumerable, whatever that means, properties and its prototype chain. So all the properties that you have, and it goes up its prototype chain. The keys method returns an array with only the enumerable properties name, all the its own that's important here, property names of an object. Okay, so its own properties, not something it got from its prototypes. Okay, there's one other method we can use to look at these things. It's object dot get own property names, and then we can drop in any object we like. My object B. Okay, it only shows its own properties, none of the ones that it gets from the prototype chain. Okay, now if we create new properties or assign or update properties on an object, they're assigned to the object and not to its prototype. So let's take a look. Okay, remember my object C had two fields of its own, music and guitarist. Okay, my object C.number it got from object A. Okay, my object obj C dot course it got from object B in its prototype chain. Okay, now what happens if I go I'm just going to type it out, C dot number equals 7. Do you think that messed with object A? My object A, because that's where the number came from. No, it didn't. What if I set course on that? My object C dot course equals web development. Okay, where did course come from? My object B, I think. JB. Oh, it didn't change it there. So basically, if we add or change a property that's up the prototype chain, it will actually not affect those things. Okay? Is this behavior useful? Yes. It allows sharing of functions and properties, and it prevents accidental overwrites. Okay? This kind of hints at inheritance, right? Object B inherited a bunch of properties from object A. Okay? Nice. So, this is called prototypical inheritance. Okay? We looked at one piece of it, the proto field. The piece that we didn't look at is object constructor functions with their prototype and constructor properties. We didn't cover those here. Okay, not strictly necessary because we're not going to ever use those mechanisms in this class. The references cover them very well. This provides the basis for pretty rich inheritance modeling. Okay, so we're using a completely different approach to getting inheritance than maybe C++ or Java. Okay, and it's going to give us though enough. This gives us enough base features to give us just about all the inheritance type of properties we want. Okay. The use of these raw mechanisms, though, not the proto, but even the proto, but the ones associated with constructor functions for creating inheritance hierarchy is error prone, it's putsy and klutzy. Okay. So ES6 introduced classes, and we'll see this in a second, to help us out. The classes don't add anything new underneath, but they give us much easier, less error-prone syntax, more readable syntax to set up prototype inheritance hierarchies and provide access to parent functions, all that good stuff, okay? So they just make it easy to use. The underlying mechanisms are fine. Okay, if you have to use them in the raw in an older browser, okay, I hope somebody's paying you, because they're just kind of ugly. Let's look at the nice, easy approach. Okay, let's create a class with the modern syntax. Okay, so we just say class, give it a name. Okay, by convention, I'm using the capital letter here. Okay, then I have something specifically named function here, constructor. Okay, in the constructor, I have to create all the properties of object to be are associated with this. Okay, this dot year, this dot make, this dot weight. Okay, we're kind of used to this. Okay, we had a whole section on this. We know its purposes for when you create new objects. Okay, so we have to put all that stuff in the constructor. Now we can have nice simple method definitions. Okay, here we have let's see, this return, this year, this make, this style board. Okay, and sale recommendation, blah blah blah. Okay, so let's try this. I mean, this class definition. Okay, I'm just going to clear that out. So we can see it easier. Okay. First of all, it worked, meaning the code didn't crash. So, okay. Next, let's use it. Okay. Copy your code, paste it in. Let's just try a couple things first. Okay, so we're going to create a new board, and then we're going to try calling its about method. Okay. So what did I say? var b1 about. Okay, about tells me that it's a 2010 Mike's Lab formula board. Okay, so it took information from the year, the make. Okay, we didn't use anything about the weight. Okay, but that's there. Oh, let's try the sale recommendation. Formula sales. Doesn't seem amazing. Okay. Ooh. Let's try looking at these prototype chains. Okay. Proto object v1 proto. Okay. Oh, constructor class board. Oh, it's got all these other things sitting in its prototype. Ah, that's where it gets its function about from. Okay, it's getting its sale recommend. Oh, those are all there. Okay, cool. Now let's look at b1 underscore underscore proto dot constructor. Ooh, it says class board. And our final thing, we ask if it's an instance of board. Okay, so underneath, okay, we didn't talk about the constructor properties and such like that. Okay, because we don't need to worry about those anymore because we've got classes. But underneath, it's using this proto and the proto constructor thing to do this. Okay, instance of works with the classes. So we never need to be concerned with this proto stuff underneath unless you're working with legacy code. Okay, but it's there. Okay, but the class took care of it for us. Okay, some key points. Notice that class, okay, what does this mean? Classes can only contain method definitions and not data properties. Huh? We had a bunch of data in here. Oh, wait, but this data, these thises, okay, all the properties were defined in this constructor. There's no freestanding data in here. Oh, that's why. There's no freestanding data in here. Okay, that's what they mean. Okay, so this does not look like, it starts to look like here, maybe it might be an object, but this is not the same as an object. Okay, this is a class. Okay, this is a class. So everything in this class is actually a method. Okay, including the constructor, which is a very special method. This is where we define all our properties. Ah, gotcha. Okay. When defining methods, you use the nice shorthand method definitions. Unlike when creating object literals, do not separate method definitions in the class bodies with commas. No, we don't separate. Here's a function. Okay, no comma here. So this is a class, not, okay, its syntax is appropriately different than what we have for objects, object literals. Okay. Now, I'm very sorry, but we're going to use a classic uh, animal inheritance hierarchy to illustrate inheritance. Why? Because it's fairly straightforward. So here's a class mammal. Okay, we're going to start with this class. Okay, let's copy it, paste it, construct it. Okay. Now, to extend or inherit from that class, okay, whatever that means, we'll review that. Okay, we go class marsupial extends mammal. Okay, so we can add whatever we like, more fields, more properties, whatever, to the extended object. The one thing we have to do is, in the beginning of our constructor, okay, we need to call super. Okay. Why? Because that calls the parent constructor. Okay. Let's copy this. Bring this over. Paste. Okay, so we created another class. Okay. Let's try using these. Okay, copy them all. Let's execute them a little bit at a time. Okay, so we're going to try going new mammal, kitty. We're going to ask it its locomotion. We're going to ask it to speak. Okay, let's try, go back one step, the locomotion. Usually walking, but not always. Okay, now let's try a new marsupial, a Tasmanian devil from the, okay, some kind of marsupial sound. Mars 1, Aussie. The answer is likely. Oh, gotcha. So there's extra properties. What else do we have in here? Locomotion. Okay, so it inherited locomotion, okay, from the mammals. What else do we have? Object keys. Array. Okay. Object keys marsupial. Okay, backbone neocortex, name, pouch, Aussie. So we get everything out. Object keys mammal 1. We get backbone neocortex name. Nifty. Okay, nice properties. Okay, nice, easy inheritance. If you like, you can look at the entire prototype chain to see if it's set up. Okay, should we not? Oh, let's do it for reference purposes. Let's start at the top. Okay, we looked at mammal. We looked at mammal prototype as just object, okay. We looked at mammal1 prototype constructor, class mammal. Then we went to look at marsupial. Then we looked at class marsupial. Then we looked up the chain. We see mammals and such like that. Okay. I sure don't want to have to define these things by hand. The class structure, the class syntax did all that for us. Try instance of. Make sure this all works. Okay. Whoops. Problem is, too many things at once. Let's see. Mam1 instance of mammal. Yes. Oops, not that. Marsupial 1 instance of mammal. True. Marsupial instance of marsupial. True. And finally, mammal1 instance of marsupial. No, as we expect. Okay, inheritance working like we want. Okay, some key points for extend. Subclasses are declared with the class keyword, followed by an identifier, then the extends keyword, followed by an identifier. Okay, if your derived class needs to refer to the class that it extends, you can do this with the super keyword. Okay. A derived class can't contain an empty constructor. You must call super in the constructor of derived class before you can use this. Okay, gotcha. Super duper stuff. There's two use cases for the super keyword within subclass constructor calls and to refer to methods in the superclass. Okay. Derived with normal method definitions, derived class can refer to methods in the parent class with dot notation, super dot method name. Okay. Now, why would we use inheritance at all? Okay, we aren't going crazy. We're not doing animal or other modeling hierarchies. One of the main places is where we work within a framework. Okay. So you inherit their classes, from there you extend, in the JavaScript terminology, their classes, and then you add more functionality that the framework expects you to add to work with that. And we're going to see that in this class when we do React class components. All right. JavaScript prototypes, inheritance, and classes.